To understand the logic behind the 2SLS approach and how to solve the problem of endogeneity or simultaneous equation bias, let us go back to Tutorial 1. In Tutorial 1, we defined the simultaneous equation bias and the source of that bias. In the simple model shown here, we were able to show the source of the bias by substituting the first equation of y into the second equation. When we bring x to the left-hand side and rearrange, we are left with the equation shown here. Here, we can see that x is a function of exogenous variable q. But x is also a function of the error term mu. This error term mu appears in the first equation of y, which means that the independent variable x and the error term are related in the first equation. This causes bias in the estimates. The 2SLS approach gives us a solution to this problem of endogeneity. If we look at the equation, we can clearly see that the bias arises from this component of the equation because it contains the error term mu from the first equation. If we can somehow remove this component and keep only the first part of the equation, then x and mu will no longer be related. The issue is, this component contains the error terms mu and upsilon which are not observable directly. But, if we look at the equation carefully, it simply expresses the variable x as a function of exogenous variable q. That is, the endogenous variable x is a function of exogenous variable q. This is called a reduced form equation which represents the endogenous variables in terms of all the exogenous variables in the model. If we estimate this equation, we can obtain all the components that we need. The error term epsilon shown here contains the component that causes endogeneity and bias. By removing this error term epsilon and keeping only the reduced form coefficients and exogenous variables, we can get rid of the bias problem. This is exactly what 2SLS does. Now, let us take a look at how we can accomplish this using the 2SLS model with an example. Let us continue with the same example we used in the previous tutorial on identification. In this demand-supply model, we have three endogenous variables: price, quantity demanded, and supplied. We also have three exogenous variables: income, price of substitute, and cost of raw materials. The variable price, which appears on the right-hand side of the equations, is endogenous. This means that this independent variable of price is correlated with the error terms of the demand and supply equation. This is the only endogenous variable that we have to worry about because the other endogenous variables of quantity demanded and supplied appear only on the left-hand side. Only price appears as an independent variable in the equations and will lead to endogeneity and bias. In the previous tutorial on identification, we determined that the supply equation was over-identified. Suppose we want to estimate this supply equation, we can do it using the 2SLS approach. In the supply equation shown here, we know that the independent variable of price is related to the error term upsilon. This means that OLS estimates will be biased and inconsistent due to endogeneity. Therefore, we will use the 2SLS approach to solve the bias problem and estimate this supply equation. Here, we have to keep in mind a few things about the 2SLS model. First, this model is applied in two stages as the name suggests. We will discuss the details of both stages shortly. Secondly, 2SLS is a single equation approach to simultaneous equation models. This means that we estimate the equations one by one using 2SLS. For instance, in our demand-supply model, we have to apply 2SLS to the supply equation and the demand equation separately and one by one. This is different from methods such as 3SLS and FIML, which estimate all the equations of the model together or simultaneously. In stage 1 of the 2SLS model, we have to estimate the reduced form equations of endogenous variables. As discussed earlier, reduced form equations express the endogenous variables as function of all the exogenous variables. In our example, P or price is the endogenous variable which appears on the right-hand side and causes endogeneity and bias. Therefore, its reduced form equation will express P as a function of all the exogenous variables in the model. Our demand-supply model has three exogenous and predetermined variables: income, price of substitute and cost of raw materials. In the first stage, we have to estimate the reduced form equation shown here. As discussed at the beginning of this tutorial, the error term epsilon is the component that is causing the problem of endogeneity and bias. The remaining component, including the exogenous variables and reduced form coefficients, will not lead to endogeneity because this part is not related to the error term upsilon of supply equation. We can obtain the predicted value of price or P cap. The error term or epsilon has been removed from this P cap component. Hence, we have managed to separate the component causing endogeneity using OLS in this first stage. The predicted price or P cap is separated from the epsilon component that caused endogeneity and can be used in the second stage of 2SLS. In stage 2 of 2SLS, we use the results from the first stage to estimate the supply equation. In stage 1, we obtained the predicted values of price or P cap from the reduced form equation. Here, we use those predicted values or P cap as an instrumental variable for P or price. As a result, our supply equation will look something like this. The variables quantity supplied and cost of raw materials stay the same, but the endogenous variable price is replaced by an instrumental variable P cap. This works because P cap will not be related to the error term upsilon in the supply equation. The component causing endogeneity and bias was removed in the first stage of 2SLS. In P cap or predicted price, we are left with the component that is not related to the error term. If the equations and exogenous variables are correctly specified in the model and the first stage, the 2SLS will give reliable results because P cap will be a good instrumental variable for price. This is because P cap will be highly correlated with price but not correlated with the error term upsilon. This procedure has been observed to perform well in practice and gives reliable results as compared to biased and inconsistent OLS estimates. Next, let us discuss the benefits of using 2SLS and some things that we must watch out for when applying this model. In the presence of endogeneity and simultaneous equation bias, the 2SLS model has some clear benefits over OLS. Firstly, we know that the OLS estimates are biased in the presence of endogeneity when an independent variable and error term are correlated. In this situation, applying 2SLS gives better results. In small samples, 2SLS estimates are still biased. However, the estimates are asymptotically unbiased. That is, the bias tends to zero in larger samples as the sample size increases. Secondly, the OLS estimates are not only biased but inconsistent as well. This means that the estimates do not converge towards true parameter values even in large samples. On the other hand, 2SLS estimates are consistent. That is, as the sample size increases, the estimates converge towards the true parameter values. Finally, to estimate an equation with 2SLS, it is not necessary to know the entire structure of the simultaneous equation model. We only need to know the variables in the given equation and the exogenous variables that are not part of the equation. For instance, let's say that we want to estimate only this supply equation where price is endogenous. We only know the structure of this equation and have no knowledge of the exact structure of the demand equation or other equations that might be in the simultaneous equation model. We can still estimate this equation with 2SLS if we know the exogenous variables that can act as instruments for predicting P cap. In the first stage, we need other exogenous variables alongside R to estimate P cap. If we have knowledge of those exogenous variables that explain price, we can use those in the first stage. These could be variables such as income, price of substitutes, government policies, tastes and preferences, etc. that affect price. Therefore, we don't need to know the complete structure of other equations, we only need to know the relevant exogenous variables that can be used to make the equation identified and predict price or P cap. There are a few things that we must consider and ensure before applying 2SLS. First, we must make sure that endogeneity and simultaneous equation bias are a problem. We can apply the Durbin-Wu-Hausmann test for endogeneity to check whether an independent variable is truly endogenous. We will discuss this test in the goodness of fit part of this tutorial series. We should apply 2SLS only if there is endogeneity, otherwise, we are better off using OLS. Second, we must make sure that the exogenous variables in the model are truly exogenous. This means that the variables that have been considered exogenous and used as independent variables in the first stage must not be endogenous and correlated to the error term of the equation. If any of these variables are not truly exogenous, the model breaks down. Finally, the exogenous variables that are used as instruments in the first stage must be relevant variables that can predict the endogenous variable. If the instruments are weak, they won't be able to accurately predict the endogenous variable and the final results of 2SLS will suffer. We will also discuss how to determine if the instruments are weak in the goodness of fit part. Thank you for watching and I will see you in the next tutorial.